Hi everyone, welcome to the telecommunication track at AWS event. In this session, we will introduce Telefónica Germany's remarkable innovations coming in the 5G, titled Enabling Industry 4.0 with Ericsson's 5G and Edge Cloud. My name is Tetsuya Nakamura, a Senior Partner Solution Architect in AWS. It's my great honor today to have Johann Bachheld, Director at Network Core and Services from Telefónica Germany, and Rishi Bhaskar, Head of Hyperscale Cloud Provider from Ericsson, to talk about our three-way collaboration and the target use cases. Here's today's agenda. First, Johann will cover 5G challenges from an operator's point of view and share why Telefónica, Ericsson, and AWS have worked together very closely. Then, I will talk about how Ericsson's cloud-native 5G network function is implemented with AWS services, especially using our edge cloud infrastructure called AWS Outposts. Rishi will explain both business and the technical value, as well as introducing our target use cases. Lastly, Johann will make a conclusion and mention about our next step. So now it's time to listen from Telefónica Germany. Please welcome Johann Bachheld, who is leading Network Core and Services Group from Telefónica Germany.
Thank you, Tetsuya, and very warm welcome from my side to all listeners to this stream. It's exciting to talk about the journey that we have in front of us and that we have started together with AWS and Ericsson on how to build a 5G core network enabled on the cloud environment. Let me talk a bit and look a bit about into the challenges, but not only into the challenges, also in the potential that we will see with 5G. So I think the first and main important message here is that we should look into 5G not as just another technology like 2G, 3G, and 4G, but looking into it as a platform. So 5G will be a platform enabling new use cases, and with that helping in order to monetize new businesses, new use cases. What will help us in order to monetize or to create new business models are the capabilities of 5G, like low latency realized via edge use cases, or the capability of managing applications across different ecosystems, mainly using orchestration. So all in all, the cloud journey that we have in front of us will help us to bring forward significantly the flexibility and the capabilities we can offer with 5G, but also improving and helping us to deploy faster and quicker our solutions to customers. On the next slide, I've just summarized some of the challenges we have today. The challenges we have is mainly on time to market from today's perspective. Then we have to be more flexible in developing new business models compared to today. So today it will take us approximately 6 to 9 months to develop a new feature, a new functionality. We need to be much more flexible and faster here. And lastly, we also have to look into what is the customer experience that we offer with that. So what are the quality of service parameters, the AI, ML capabilities that we use in order to better understand our customers. And looking into the challenges we have, I think automation will play quite a key role in order to fastly deploy new infrastructure, to deploy infrastructure on demand, to also deploy new business models and new features and functionalities faster using automation, end-to-end automation. New business models will be mainly enabled by the capabilities of 5G and the increased flexibility. Flexibility, as I said before, delivered by automation, by full end-to-end automation, will be also enabled by deploying the infrastructure, the core network infrastructure closer to the customer side, so meaning on an edge location. And this will be specifically important for industrial customers in order to help them building their ecosystems close to where they have their factories or close to where they have their use cases and their areas where they provide the different use cases. An important piece here will be also the openness on interfaces that we need to offer in order to integrate with third parties. And that's an issue today, or not an issue maybe, but a limitation that we have today, that telecoms networks are usually quite close. So it's hard for third parties to integrate and to leverage the information or the capabilities out of that. And then lastly, the aspect of network sharing, so building individual network slices or parts of the network for industrials, for customers, will play an important role, because security, also the availability of the service, the reliability of the service will play an important role. And all this will be enabled by 5G as a technology and powered by the capabilities of a cloud environment, bringing the flexibility, bringing the tools in order to fastly deploy, to slice the network, and also later on, from a user perspective, to better understand, using AI and technologies, what our users are doing, how do they behave in the network, what is the service quality they perceive. So all this will be the challenges we have to address with 5G. And we have decided to start this journey together with AWS and Ericsson. And let me explain on the next slide a bit why we choose this partnership, this strategic partnership, and who is providing what kind of benefits that will make it successful in the end. So we have at first the 5G core network provided by Ericsson. Ericsson is a network equipment provider, a network solution provider since many years, so very experienced, have rebuilt the entire core network applications to implement it in microservice architecture, to implement and run it on container services like Amazon EKS services, which will be the key enabler for that. Second part is Ericsson already have great experience in the orchestration and management of services, so meaning the enabling or the orchestration of different service components of the core network, of the use case, to bring them together on different environments. This in combination with the tools provided by the cloud environment and the capabilities of spreading out the core network towards the customer, towards the industrial partners, provided by AWS Outpost solution, will bring us in the right and perfect position in order to build new use cases. So Telefónica's play will be to provide the edge locations in order to serve the customers, and also working together with the customers in this trilateral partnership to develop the use cases. So all in all, you see that not just one part of us or just one piece of it can deliver the whole value chain. It's the three of us in this trilateral partnership. And if we go on the next slide, I think it's clear that we only together can manage to build this new landscape of cloud technology. Telefónica, for example, by providing the spectrum, providing the devices. Ericsson, as I said before, by providing the core network technology, bringing the experience and knowledge in how to build use cases, and also to migrate from the classical telco landscape into the cloud environment. And AWS, with its broad portfolio of cloud solutions, in this case we will use the Outpost solution. We will also rely on the central solution. So all in all, we will have the chance to build here a new reference for business value, created with a 5G core network on cloud environment together in this trilateral partnership. And now I'd like to give back to Tetsuya in order to explain us a bit more about what is the architecture, what is the solution to be implemented.
Thank you, Johan. Followed by previous Johan's statement. So in this part, I'd like to explain how Ericsson and AWS try to solve their operators problem. So especially, I would like to explain how Ericsson's cloud-native 5G core network function is implemented using our AWS services and APIs, especially focusing on edge cloud infrastructure called AWS Outposts. Also, I'm a little bit touch about Ericsson's orchestrator integration with AWS environment. Telefónica Germany, Ericsson, and AWS joined force to develop an enterprise solution for Industry 4.0 customer. To achieve that goal, we have worked together very closely to build 5G standalone private network solution on top of the AWS Outposts. AWS Outpost is deployed in Telefónica Germany's edge data center or enterprise customers' on-premise environment, where all the Ericsson's 5G core network function, including UPF, SMF, AMF, and others are on top of. On the other hand, Outpost OEM functions such as monitoring, logging, and health check, those kind of a more OEM function run in the AWS region cloud, so that AWS can provide the whole horizontal single pane of glass unified management for NFV infrastructure. Also, in the customer premise applications such as industry IoT or latency sensitive MEC application are deployed on the same outpost serving enterprise customer with 5G new radio access network and CPE. The main purpose of this ongoing POC include end-to-end orchestration and exposure of the solution using Ericsson's Orchestrator, which are integrated with AWS various APIs for resource management and workload placement based on network KPIs. So in here, I'd like to categorize into 3 key features. And what kind of AWS services and API are consumed to achieve the Ericsson's 5G core private network function solution. So first, for deployment of Ericsson 5G core standalone network function as part of the private network and also enterprise application on the same outpost, we use AWS managed Kubernetes service called EKS, and also relevant computing, storage, and networking services called EC2, EBS, VPC, direct connect accordingly. Second, for integration of AWS APIs to Ericsson Orchestrator, we use several bunch of the exposed API and tools such as CloudFormation and a serverless function called Lambda, as well as monitoring and a logging tool called CloudWatch and CloudTrail. Those AWS tools and APIs allows Ericsson's Orchestrator to control AWS resources in a more flexible way, even the fact that the Ericsson's Orchestrator itself does not run on the AWS environment. And the third point is for orchestration of the end-to-end service via Ericsson's Orchestrator. We use CloudFormation along with our managed container registry services called ECR and also EKS, our managed Kubernetes services, in order to make Ericsson's 5G core deployment easier and automated as much as possible. Going into detail, so while the OEM function can be centralized on AWS region cloud, to effectively package all the 5G core network function in a box and to provide the ultra-low latency applications to the end consumer, 5G core network function along with the MEC applications can be deployed on the outpost in the edge data center or enterprise customer premise as shown in the right side. NFV infrastructure OEM interfaces must be through the hybrid network connectivity between AWS cloud and the operator's 5G networks. AWS Outposts need a service link establishment back to the AWS region through either AWS Direct Connect or VPN over the public internet. However, in the case of the 5G network implementation, given the fact that all the CSP requires a very carrier-grade SLA requirements in the context of the connection, network connectivity, like bandwidth or jitter or latency, most likely our direct connect is a more reasonable and valid choice. Also, Outpost has a local gateway, which is a local interconnect virtual router that can be used to connect with the on-premise local network. So which means is that the local gateway supports BGP dynamic routing or static routing so that all the N3 and N6 user plane data traffic goes through the local network to a radio access network or the internet accordingly. In Kubernetes environment, networking service exposure to receive the traffic from the external network must be done through Kubernetes ingress, usually using with a local load balancer. However, in some cases, such as UPF, Network function built in the cluster must receive all types of the traffic distinct to IP address of numerous mobile devices and CEs, which makes very hard for us to use a load balancer. Besides, depending on the design of a CNF, cloud native function, some CNF homegrown load balancing pod can require multi-homed direct interface to the external network for serving legacy protocols such as HTTP, because HTTP is a very typical mobile network protocol. But in such an environment, many of our Ericsson's pod like SML and UPF requires a multi-homed pod is required for implementing CNF on the Kubernetes. This diagram shows how to automate those kind of a very complicated process for self-managed worker node group with multiple network interfaces. We can automate those processes to attach additional interfaces to the worker node using CloudFormation and the CloudWatch event and a lifecycle hook triggered by Lambda function and a serverless application repository. Given that 5G network will be much more complicated in terms of the heterogeneous network environment, as well as microservice-based architecture, CNF, Cloud Native Functions Lifecycle Management, should be fully automated to maximize the efficiency of operation in scale, and also, most importantly, how to minimize the operation cost. So this figure shows how to automate Ericsson's 5G core network function deployment and lifecycle management. CloudFormation and Management Console enable to create a VPC environment, including a public and a private subnet, a route table, internet gateway and NAT gateway, and the security group configurations. AWS managed Kubernetes service called EKS help self-managed cluster creation, and Lambda-backed custom resource in CloudFormation template triggered by CloudWatch event can assign EKS worker node group with multiple network interfaces. CNF-specific configuration can be also set by our command line interface, and also like Ericsson's very specific Helm chart can be using on board using our HR and so on. In case of EKS cluster, worker node need to get increased during the lifecycle management after the instantiation. For example, depend on the on-demand traffic is increasing from even in the daytime. If that's the case, those kind of events trigger the auto-scaling using the CloudWatch event, because all the traffic is continuously monitored by CloudWatch. And the auto-scaling in and out is quite automated, like in here. And also, most importantly, is Ericsson's orchestrator can control the whole of this entire procedure through AWS API networking. As mentioned just before, that's the most important aspect to operate, how to operate such a kind of heterogeneous, complicated operators network. Ericsson's orchestrator can control the entire procedure through AWS API interworking to enable programmable orchestration. It means all the EC2 and other service API are called by orchestrator directly or using a CloudFormation. In the current implementation, Ericsson orchestrator and element management entity is not up and running on AWS environment, but rather deployed in the customer's operators network. This allows us to fit with the existing operator environment, as well as make it easier for hybrid integration operation with other underlying infrastructure, because many of the large CSP, like Telefónica Germany, has a different already existing footprint. So Ericsson's orchestrator leverage AWS service natively and develop using AWS managed Kubernetes service and so on. This approach results in the creation of orchestrator is fully built in microservice-based flexible architecture. This is very critical aspect because the complexity of the 5G orchestration tool will continue to increase as new service cases get added. So that's why those kind of microservice-based architecture will secure that Ericsson's orchestrator can be further developed and enhanced in a more agile and flexible manner. So now it's time to listen from Ericsson about both of the business and the technical value, and also our target use cases. Please welcome Rishi Bhaskar, who is leading hyperscale cloud provider group from Ericsson.
Thank you, Tetsuya. Now we'll shift our conversation to business and technical value away from architecture and design. And what I'm going to talk to you about today is how we see 5GC enabling high-value use cases, not only for consumers, but more importantly for enterprises. So if we look at the next chart, we talk about the pure distinction between 5G for consumers and industry. And I'll start highlighting a little bit of the value of consumer-based 5G, and then we'll move into high-value use cases for industry. What we see in the near term is that 5G is going to bring a lot of benefit to consumers. First off, alleviating urban network congestion, but also with the advancements of 5G and fixed wireless access technology in 5G, we're going to be able to bring more home broadband choices to our consumers. Additionally, we see the uptick in 5G adoption by our consumers, not only monetarily, but from a subscriber base. We expect subscribers that will be willing to pay at least 20% more for 5G services than they do today for 4G services. And then lastly, as we all know, the consumption of data is going to skyrocket once 5G becomes pervasive. We predict 1 in 5 subscribers will leverage about 200 gigabytes of data every month by 2025. So significant increase of usage by our consumers. But now let's shift our focus over to the industry. We believe 5G will revolutionize industry digitalization. And we actually, based on our research, understand that this market opportunity for our customers ranges in the $700 billion total addressable market across multiple verticals over the next 10 years. And if you look at the graph here, we see manufacturing as potentially the largest consumer of 5G in that digitization or digitalization process, followed by healthcare, then moving into energy and utilities, automotive, and ultimately public safety. The really important thing to note here is that the adoption of 5G by the various industries and the size of that potential market is all tied to a couple key enablers. And those enablers are, 1, mission critical technology, but 2, low latency use cases. So in manufacturing, in public safety, energy, utilities, automotive, those low latency use cases will now become a reality in 5G, which is why we see the market opportunity so large in adopting 5G and moving down that digitization path. I want to double click a little bit on manufacturing. Manufacturing from a 5G perspective really enables that digitization process, and it allows you to unlock your lean, mean, and green capability in your manufacturing facility. Lean meaning that digitization will enhance automation, mean being allowing you to digitize and leverage the click-to-buy supply chain, and of course, green, creating sustainable manufacturing environment in your facility. And there's no better place to look than Ericsson, that actually built 5G smart factories in Lewisville, Texas this year. So looking forward to unlocking this potential for industry digitalization with 5G. So if we move to the next slide, it's not just about unlocking this potential, but how do we actually step by step leverage the value chain that can be unlocked with 5G infrastructure. So we talk about transforming businesses. Well, we know we're going to transform enterprises, but we're also transforming our telecom operators to become software-based operators. So as we move down the digitization path, software-based solutions from our telco friends like at Telefónica really enable digitization of enterprise. And then a couple other features that are really unique to 5G are things like unique deployment models. So we created in 5G the ability to create network slices that are very specific to use cases, user groups, segmentations of industries. And then if you take that concept of targeted use cases via network slicing that may be built on a higher quality of service, as an example, for a particular use case, and if you can move that all the way to the edge, we're now going to be able to unlock those low latency use cases with targeted network slices, looking at this from an end-to-end perspective. And then the other thing I want to point out, One thing that really helps unlock the power and value of 5G for industry to go out and create that $700 billion addressable market is the ability to provide standardized open APIs. What we've done in 5G is we've created this network function architecture. So there's multiple network functions that obviously map to certain value for a 5G core. On top of that, we've enabled something we call network function exposure. And network function exposure allows standardized API access to network functions. So what that really means is we can unlock the power of the developer community. So if you think about what AWS brings to this environment, they have millions of developers that are certified AWS developers. We have now taken away the complexity of the network infrastructure via exposure and allow those developers to do what they do best, innovate on top of our platform. And that is really going to unlock the application space that will take advantage of low latency, high throughput, reliable 5G networks. So we're very excited about bringing that developer community into our ecosystem. And then lastly, we're going to march down a journey of creating new businesses and new ecosystems. We saw it happen in 4G. We believe that'll happen 10 times over in 5G. And creating those new business ecosystems and environments will not only be leveraged by enterprise, but certainly leveraged by our consumers as well. So the really interesting opportunity here is, if we move to our next chart, is really looking at that total end-to-end ecosystem. And whether you are in any one of these industries across the bottom of the chart here, really the key thread here is connectivity and infrastructure. Once 5G becomes much more pervasive, we're starting to see already the service enablers and the application services on top of the infrastructure allow us to unlock these various use cases. And even going all the way into 5G enterprise networking, we have the ability now, with the examples that Tetsuya laid out architecturally, to get right into the enterprise with our service enablers. And that is a common thread, is enabled by 5G connectivity and infrastructure. And so if we look at one of these use cases in specific, we look at smart surveillance. Smart surveillance, given the environment we live in today, is a very key technology. So we could do smart surveillance in 4G. We can do smart surveillance on fixed networks or Wi-Fi networks. But what's the true value of the mobile network and cellular unlocking smart surveillance for, say, communities across the world? When we look at our ability to not only stream live data from 5G, but if we take our deployment model, like we're doing here with AWS and Telefónica, and push to the edge, and we move that computation power to the edge, not only are we going to have smart two-way video, but we're going to have the ability to provide analytics on that video real time, because we're out at the edge of the network. And once we're out at the edge of the network, we're going to provide analytics, but then the real value add is what do we do with that data? Once we can provide that analytics on the edge, we know we'll be able to deliver the right data to the right person at the right time in very, very rapid fashion, leveraging our 5G infrastructure in the deployment model we are looking at with Telefónica, with AWS and cloud infrastructure. So with that, I just want to wrap up by saying on the next chart, we believe our 5G infrastructure, coupled with cloud deployment models, coupled with our operator partners, really unlocks the world of use cases. And it is our ambition to become the digital enabler for enterprises globally. Thank you. And now I'd like to pass it back to my friend Jochen from Telefónica.
Thanks, Rishi, for giving the overview about the business and technical values provided by the cloud-based core solution. Let me now summarize, after we have heard from Tetsuya, the details about how the solution is implemented, and from Rishi, how we can make and how we can create new business value out of it. In our trilateral strategic partnership, we intend to implement a fully managed 5GSA private network. We are quite advanced in this, so we have implemented the Outpost solution, implementing the core solution on top, and this is what we will complete by end of the year. Looking then forward into next year, it will be the time for commercializing the solution. in order to build the first use cases with industrial partner on it. And we are already in talks with with big industrial players in order to define the use cases relevant for them and implement them. So all this will work on the private network solution implemented from Ericsson on top of the Outpost solution from AWS. And then starting from there, once we have implemented the first use cases, we will enlarge the scope in order to look also into open RAN solutions, and later on also building use cases with different additional industrial partners, using network slicing as a capability, so in order to use the infrastructure multiple times that we have built. With that, I'm really looking forward for the exciting journey. Would like to thank you for your attention.